after discussing the effect of surface area on the rate of reaction, I'm now going to proceed to lesson 8.4, temperature and the rate of reaction. This lesson can be found at page 110 to 112 of your course book. So I would like you to look at these words here. This will give you a hint on how to understand our lesson for today. Higher kinetic energy, higher tendency that the molecules will collide. We are still focusing our attention to collision theory. So the frequent the collisions of molecules, the faster the reaction would be. So now we will discuss about the effect of temperature on the rate of reaction. The higher the temperature, the faster the rate of a reaction. In many reasons, a rise in temperature of 10 degrees Celsius causes the rate of reaction to approximately double. So here, just like the surface area, if we increase the surface area by making the solid reactant smaller, we are also increasing the chances of collisions among particles or among molecules. Here, we are now looking at the temperature, wherein if we are going to increase the temperature of the reactants in a chemical reaction, we can make or we can increase its activation energy or the kinetic energy needed by the particles to move faster. Okay, so if the particles are moving fast, of course, there is a bigger chance that they will collide to each other. And the more the successful collisions would be, the faster the reaction. At a higher temperature, particles have more energy. This is what I meant by activation energy. So as they move, we also know that energy in motion is kinetic energy. So molecules have kinetic energy if they are moving. So increasing the temperature, making them move faster. This means when they move faster, they are more likely to collide with other particles. When the particles collide, they do so with more energy, and so the number of successful collisions increases. It doesn't mean that we will boil the reactants, because for example, if we are using acids, we cannot boil the acid because it is dangerous. So it only means that we could warm up or increase the temperature by 10 degrees Celsius by using, like for example, hot bath. You know already that one, wherein if we have a substance in a test tube or in a container, we will just put it in a previously boiled water. So we can increase the temperature by doing so. This is another graph. It's just the same. It looks like the same graph about for the surface area. But then this one is discussing about the effect of temperature in the rate of reaction. So here we have two graphs, one in blue and one in red. The blue one is using higher temperature and the other one is low temperature. So if we're going to use our ruler in determining the steepness of the line, we can see that this line over here under high temperature is steeper than the line that we can form under low temperature. So this one is giving us a conclusion that using higher temperature in the reactants will give us a faster reaction. So for like what I told you also in the using the surface area or the larger surface area, it doesn't mean that if we're going to use a bigger solid, the reaction will not happen. It will still happen, but if we want to increase the rate or we want to speed it up, we can increase the surface area. Same as the temperature. It doesn't mean that, for example, if we are using hydrochloric acid under room temperature, and reacting it to magnesium metal, it doesn't mean that it will not react if the hydrochloric acid is not hot. It will still react, but if we want to increase the speed of the reaction, we can warm up the hydrochloric acid by using warm bath or hot bath. Okay, so here, for example, we have the graph here. If we're going to put the line using our ruler, we can have this drawing over here. So if you still do not know how to analyze a graph, you have to use your course book. You can find this in page 105. Use your ruler there. Like for example, here I will let you see. I'll just erase first this line, so you will know what I am talking about. Let's say you are given a graph like this, and you want to know which is steeper. So for example, we will be using ruler in making a line. So let's analyze first for the blue line graph for the higher temperature. So if you're going to use your ruler, of course, you're going to make a straight line along the graph. Okay, along the graph. This is one. And then if you want to do another one, it would be like this. And the third one is here. Okay, so if you will analyze, the more it becomes upright, the steeper it is. See, the position is somehow upright near to a vertical line. The second line that we did is slanting, or it is curving. So meaning it is less steep, telling us that the reaction is slowing down. And at the end, it becomes flat horizontally. So it tells us that the reaction had stopped already. Okay? It's the same thing also as if we're going to put that in the red graph, in the red line graph. So here, if we're going to put a line, another here, and for the last one, we like this. Okay. So if you will see, they are following the same rule. But at the end, take a look. The volume that is made when we use a higher temperature reactant and a lower temperature, still the same. They meet at the same amount of product used. So meaning, there is no change at the end of the product used for the volume or for the amount. We are only changing the speed, not the amount or the volume of the product. Okay? So that is how we are going to analyze the effect of temperature and surface area. So for summary, the rate of reaction can be affected by surface area. So the larger surface area or the larger exposed area, by making the size of the solid reactant smaller, increases the chance of collision or higher collision of particles, making the reaction fast or faster. And with the temperature, increasing the temperature increases the activation energy or the kinetic energy needed for the particles to move. And when they move more, there is more chances that they will collide to each other, or they will collide frequently, and the reaction will happen faster. Okay? So that is all about lesson 8.3 and 8.4. If you want more clarification and other resources, please click the link that I have given in the stream, so you will have more idea on this. Okay? Thank you very much. Goodbye.